Announcements or whatever events or anything that's coming up that may be of general interest to Kubernetes containers, etc. Could you repeat that a little bit louder? Okay. Yeah, I don't want another advertising against another group, but like we have I'm on the board for TACON for TAC, but we have a meetup too if you guys are interested in that, June 20th. The normal AV problems. Huh? Say it louder.
QCon Barcelona is ongoing this week. Videos are already on YouTube. And last I checked, Helm version 3 Alpha 1 crashed this week as
well. Okay. Anything else? I have a very, very short just thing to present to people, and it's mostly very short because all my screenshots are on my laptop safe at home. Can't be the first person who's done that. Recently, Rancher introduced a project called K3s. They said it's 5 less than K8s. And what it is a lightweight Kubernetes distribution. It's primarily aimed at doing development clusters. Those of us who have run Minikube on our laptops and watched our batteries disappear out from under us will appreciate that. What K3s actually is it's a single binary. It's written in Go. It's originally started, if you look at the full Git history of it, it actually started as Kubernetes, and they literally went in and started deleting things to make it smaller. One of the interesting things about it is part of the whole CNCF has a conformance test that they run against Kubernetes distributions. That includes like open source things like K3s, as well as things like GKE and Azure and Amazon and those types of services. But K3s actually passes that conformance test, which is pretty interesting. So you can be assured that if you write something against this little development Kubernetes distro, that it will work, in like, a real cluster as well. One of the painful parts about setting up actual clusters, if you've done this, is setting up secure communication between all the components. It's one thing that K3s does for you. And it does it, those who've ever used Atom, which is kind of the Kubernetes official way to do this, is you wind up doing this token exchange thing. So it's actually an interesting way to do that. So you wind up having this token that you just copy and paste between different machines. Not the greatest thing, but it's better than kind of like managing a CA, particularly for the target audience here, which is, developers and such. One of the interesting things is they made a lot of opinionated choices, and this is one of the reasons why they have not so much support. For example, they out of the box only support flannel with VXLAN. So that makes firewalls very simple, makes their networking kind of pretty straightforward as far as those things go. They have this very simple load balancer built in, which is basically just pick the first server that has the open port on it, and that's who gets the virtual IP. Then some other things in here. One of the interesting things is, and this is a kind of growing trend in Kubernetes distributions as well as services, is they do not, out of the box, they use containerd rather than the full Docker image or container runtime. One of the interesting things about that is containerd is much more simple and much smaller. And as those who know, that Kubernetes doesn't actually use a lot of the more advanced features that Docker offers anyway. So that's kind of an interesting thing to do to keep it simple and smaller. Obviously, if you want to think about it, if you have this very small distribution, one of the things is it has none of the alpha features in it. So if you were wanting to do some cutting edge things in Kubernetes, they're just not there. Another thing you actually do, anything that's marked as a legacy in the official Kubernetes API is also disabled. And that's one of the reasons why the conformance test, as you can imagine, if this passes it, does not check for any alpha things as well as any legacy thing. But it turns out some of the legacy things were some of those early things that were implemented in Kubernetes and were actually in some of the code past some of the larger, more bloated things as they were kind of figuring things out. They also moved all of the cloud provider and storage providers, for example, out of tree, which means, so may not know this because a lot of times, you know, either provider's doing this for you, or if you're running the full distribution, you don't notice this, but like storage providers and cloud providers, you can actually run those as out of process, well, processes that actually interact with the cloud provider, and then there's an API between Kubernetes control plane and those plugins to do that. And so by removing those out of there, they've been able to pare this down so that kind of the base, this single binary is about 40 meg. And then whenever it starts up in kind of a small cluster, you're looking at like, you know, 100 meg or so of memory for, you know, a given node, as opposed to Kubernetes itself, which, you know, it's not unusual for it to push, you know, up close to a gig for, you know, a node, particularly one in the control plane. Another thing they've done here, once again, just because of the target audience of our target market for this, is there's no HA for the control plane. They actually ripped out etcd from it, and they actually use SQLite. So that means that on the control plane only runs on a single node, and so it's just using local embedded SQLite for all of the storage that Kubernetes is normally doing, which is very interesting. If you go read through some of the issues, people are like, we should have distributed HA for the servers, and we should put etcd in there, and it's kind of like you're missing the point of that. But that is one of the interesting kind of trade-offs when you're thinking of looking at this, making it very simple and doing single node things. I thought it was kind of interesting that they did this rather than those who've worked with some of the HashiCorp products, how they do the single binary thing, but actually kind of layer, you know, Raft and those types of things in there. Just kind of an interesting approach. Whether or not you can see this, this kind of shows the model that they do, how they do it in process. In normal Kubernetes servers, those who run them, and like the control plane, each one of these, you know, parts, not the tunnel proxy, we'll talk about that in a second, is an individual process. And part of this is in some ways the strength and also a weakness of Kubernetes, in that each one of these parts is, you know, pluggable. You could actually replace a scheduler with your own thing and do all this types of things, but it turns out almost no one ever does that. They just run the normal one. So you wind up having to manage yet another process. This is if you're managing it yourself. Same thing for the controller manager, which is one of those. We could probably do a quiz and see how many people knew what the controller manager does. And then you can actually write a multiple of those. But once again, if you're thinking about the target, like I just want to run some dev stuff on this, you know, like a local host type thing, or I run this on my Raspberry Pi cluster, for example. I'm running some pods and that's about it. The same thing is done for what they call a server and the agent. And the agent's basically the kubelet, if you will, is that they're running all this in process, including they have Flannel, like we were talking about earlier. It's actually embedded in the same process, so it's not even having to spin up extra processes or anything. part of that's like making some opinions up front. One of the interesting things that it does is if you've ever, when you're running Kubernetes, and if you ever have done like, like kubectl exec or kubectl logs, and yes, I pronounce it that way, then the way that it works is you actually come through the API server, and then it makes an connection over to the node that like that pod is running on to collect its logs, for example. And that gets an interesting thing is the way that GKE does this, and they're changing this, that actually does this with SSH tunnels, which is awesome. And other providers do it in other ways and everything. And this has been kind of one of those like little dirty secrets about why things have to talk to each other bidirectional within the Kubernetes kind of a full cluster. Is what K3s does is on both sides, it starts up this tunnel proxy is what they call it. But what it is the agent actually makes a single HTTP connection over to the server, and then it upgrades to WebSocket, those who know those. And then on that WebSocket connection, it actually creates a bidirectional tunnel. And so all communication between the agent and the server are actually going over that single TCP connection, which is kind of an interesting little hack, we'll call it, if you will. But it is actually, which seems like an unusual thing to do for a development environment. So it makes me wonder, is Rancher doing something more interesting in some of their other product lines that they have this interesting proxy thing going on there. But it's actually kind of interesting because you can actually take the server if you wanted to do this, and I did this, and I don't have my screenshots that I was telling you about, but like throw the server up on a VM out in Amazon, and then run like the agent in a VM on my Mac, and have it connect through and have everything fully functioning. Now, why you would want to do that in real life, I have no idea, but it actually works, which is kind of an interesting thing to do. And one of the reasons why it works is this kind of interesting little tunnel proxy hack that they did here, which makes me wonder, is Rancher working on something interesting in that regard? So like I say, I was keeping it short and sweet to make sure that Josh had a good time. How many folks are like running like something like Minikube for local development? Anyone? Huh? Yeah. And we, I know I played with Docker has the Kubernetes. If you go click the button, I've had, I'm sorry, that's what you do. There's no command line way to do it. But I've found that they've done some interesting tuning in it that once again, like totally kills your battery. It's just, yeah. Which I guess is like their own version of kind or whatever, so. Anything else? I'm somewhat stalling for Josh to get up here. This is his hand. Sure. It's not supported in K3s, but that's the reason I was saying with the kind of the tunnel thing, that makes me think that Rancher is working on something like that, like kind of a interesting federation model or like a managed hosting of the control plane, which, you know, it's like kind of an interesting, like, why would you do that for a development environment if you weren't doing something else? So is that going over a tunnel as well? Okay, that's cool. Yeah, it seems to be that embedding various things instead of HTTP is all the rage now, because why not? I'm sure there's a Kubernetes overlay network over HTTP somewhere. All right. You want to introduce yourself, Josh?
You want to introduce myself?
Yeah, this is Josh.
Awesome, thank you. Hello, everyone. Brian Akins. Great job, Brian. Brian, a quick story about Brian. So we never actually got to work with each other, but I did work at Turner while he was working there, and I worked on the team that he worked on after he had left. So I got to inherit all of his code that he wrote. So that was, thanks, Brian. I appreciate that. Hi, everyone. My name is Josh Kurz. I work at WW, which is Weight Watchers. And I'm going to talk about GKE in production. This clicker, is it connected? Let's see if I need to plug it in. Okay. I thought it was just going to work for me, but I guess not. Okay, let's see if that works. All right, it wants me to identify my keyboard. Keyboard can be identified. Okay, that's cool. All right, my name's Josh. I like to paint. I watch a lot of Bob Ross videos. Yep, happy trees. So yeah, if I mess up, it's just a happy accident. Not worried about it. Okay, the clicker doesn't work. Okay. All right, so everybody knows all the options out there to run Kubernetes. There's a million of them nowadays. You can run. Okay, you got it? Okay, sweet. Thank you. Okay, let's go back. All right, cool. So you can run it in DigitalOcean, whatever. It doesn't matter. There's so many options. It's hard to choose from nowadays. So people are getting to the point to where it's like, what do I do? And you kind of just got to choose. So we're like recently, we've really just been focused on GKE and EKS. Personally, that's all the experience I have with the hosted Kubernetes platforms. And then when it comes to self-hosted, it's mainly kops. Sorry to say, I haven't even used kubeadm yet. So I'm super old school. I'm on kops. So why run on GKE? So Google invented Kubernetes, and they invented it a long time ago with Borg, and then they ported it over to Kubernetes. So that's one reason. And then there's all these other reasons why you would run on GKE. That's a bunch. So it's like automatic upgrades. They are from what I've seen, the fastest in terms of CVE upgrades. So as soon as the CVE comes out, they have it fixed. Whereas other cloud platform providers, not calling any names, it takes a while before they actually have it fixed. And it's kind of concerning, honestly. Logs, audit logs, all that stuff is really cool. One of the really important things is lockdown Kubernetes master APIs. So the other platforms that I've worked with, they don't even offer this. So like I have a Kubernetes master API and it's just open to the world. How do I lock it down so I can only, have a certain amount of networks hit it? Oh, well, you can't. It's not possible. So that isn't really cool to me. I don't like that. I don't want people hitting my master API from anywhere. I don't want to open to I don't want it open to the world. It just doesn't make any sense. So that's a huge thing for me. So integrated options with RBAC, with the Google IAM. We're going to touch on all these things too. This is kind of just an overview of what this presentation is going to be about. So we'll get into the details here. So GKE isn't just like amazing. There are problems with it, and like one of the problems is just complexity of trying to like dig in to it. Like once you start, it's very easy to get a GKE cluster going, but once you say, okay, cool, like I have a cluster that runs and works and I can do stuff with it, but now how do I lock down the nodes? How do I lock down my pods? And how do I do all the things that I want to do in production on this cluster? That's when things start to get a little bit more complex. And recently, I think Google's Docs have got a lot better, but in the past, for me, they've been pretty bad. One of the things I think is because, you know, the first thing you do when you have a problem, you Google search for it. So what do you get? You always get Google Docs first. All the Google documentation is like the first page of everything. So sometimes it's not I don't want to just see your docs. I want to see what other people are writing about this stuff. And it's like I have to dig at like page 10 to see Stack Overflow for any problem I'm having with GKE. So yeah, SSL too. So SSL sucks on GKE, like really bad. ACM is literally the best thing that there is when it comes to certificates. And I mean, sorry to say, Google, but you lost there, and like you really need to figure out a solution to beat ACM. So if anybody is here or watching the live stream works at Google, GCM, you can have that name. Don't worry about, you know, coming after me for it, but just create GCM and make it that easy. I know we're going to talk about some solutions that you have coming out. I know that you have some stuff, but it's still not as good as ACM still. And it's just not even close in my opinion. So that's one of the big things. SSL is like, yeah, I could talk about that. I could have a whole talk about that. Yeah, so there's some other issues, but I mean, overall, these are like the main things. Other than that, I mean, it's pretty good. So best practices for GKE. There's a lot of blog posts out there that you can go and look at. And I didn't want this talk to just be like me going and reading this blog post that I linked here and being like, okay, let me take all the things from it and just put it on the slides and talk about it. So I don't want to go in detail into all the things that are talked about, but I will say like some of the most important things like shared networks. If you're managing multiple clusters for multiple teams, you have to use shared networks. If you're not, you're going to find yourself in a world of pain in the long run, because shared networks just make things very, very simple to be able to manage. You just have your networking team, and they are the ones that are focused on your networks, and they're the ones that are focused on who has access to the networks and all the metrics that go along with that. There's tons of information there that people like experts, the expertise level of being a network expert is, you know, it's far beyond someone who is I'm not saying it's beyond, but it's just different. Like there's different level of expertise in different areas. So you don't want your networking all over the place in all the different projects and all the different accounts, because it just makes things a mess to manage. So shared networks makes that very, very simple. Best practices once you're inside of shared networks, you have to provision clusters inside of subnets. So it's a specific thing that GKE makes you do. You can't just deploy a cluster into a network and say like, all right, cool. Like here's my network, spins up the nodes, takes the IPs out of the CIDR range for the network. You have to provision a specific subnet for each cluster that you're deploying out into the shared networks. So that makes things a little tricky when it comes to how big your networks are and how you can maintain those networks over time. So if you plan on having hundreds of clusters, thousands of clusters, I don't know, you need to think about your network size, because the problem isn't the 10 dot space. The problem is the 172 space and the 192 space. Honestly, I forget. I think it's 192. So yeah, that is the problem, because you have to use those networks. Well, you don't have to. I guess you could use 10 dot networks as the sub networks, but we chose to use the smaller RFC private network ranges as our pod networks and our service networks, because we didn't want to have our pods and services on the 10 dot network, because historically that's where all of our nodes are and our VMs are. We don't want pods and services on 10 dot network spaces, because it's just going to confuse a whole bunch of other stuff that's going on. So we're trying to keep, and we also don't want people hitting our pods and services directly. We don't want that. So, and I'll talk about that as well. So by putting it on the 172 and 192 spaces, it kind of makes it a little bit more obvious for us. It all depends on your networking setup, obviously, but for us, it makes it a little bit more obvious that it's like that's something that we want very, very lower layer. We don't want anything to be able to hit it. We don't want it to be routable. So turning security, I think it used to be default that you would launch a GKE cluster. It still might be, I don't know. And you would get like, oh, cool, you get the GKE dashboard. You know, you don't want the GKE dashboard running on your cluster, no matter what you're doing, no matter what version of GKE you're running. Don't just delete the dashboard as soon as you install the cluster, because you don't want the GKE dashboard, or you don't want the Kubernetes dashboard. Like, they should have never even created that project, honestly. Like, it's not a good project. I'm just kidding, honestly. I know it was that was a cool dashboard. So also you want to turn off legacy auth and basic auth, because you don't want people authenticating to your clusters with just, you know, basic authentication. So manage clusters no pull separately. We're going to get into that later. GCP ingress controller, that is something we're also going to get into later, like tomorrow, next talk. Just kidding. And then, yeah, we're going to get into all this later, except for the blog post. I'm not going to get into that. Okay, so shared networks. I already kind of went over this in detail a little bit. I didn't, you know, I didn't wait. So I think we're good on that. I think the only thing I missed is the cloud NAT. So GKE offers a hosted cloud NAT that so you don't have to provision a NAT gateway in each of your networks. And it's actually pretty awesome. It allows you to, there's two types of cloud NAT that you can use. One is auto-scaling cloud NAT that automatically detects if you're reaching any type of limits in terms of how many port allocations you have. And if you are, it will automatically scale up the IP addresses associated with the cloud, with the NAT. But we didn't like that option, because to do that, your IP addresses of your NATs are ephemeral. And for us, NAT gateways are something that we at least like the IP addresses to be static, so that way we can lock down other networks and say, like, I want this network to be able to communicate with that network, because we're not creating VPN gateways and we're not creating, you know, direct connects all over the place. We're trying to use the public internet as much as possible. So having static IP addresses, at least at the cloud NAT, helps us do that. You know, I'm sure we could probably figure out a way to do the auto-scaled NAT and then automatically update all of our firewalls all over the place with all the IPs. But that was that next step. A next step thing. That was the first step. Is obviously we're going to manage it ourselves. And you still get all the alerts. You know, like, once you're getting to any limits, you get all the metrics and everything with the NAT. So you know, once you're getting to a certain point, if you need to scale up or add IP addresses or whatnot. So it's way more than what you get from other hosted NATs that we've seen. Way more. So we also like one subnet per cluster. To be honest with you, I tried to, I don't even know if you can deploy a GKE cluster if you can deploy two GKE clusters into the same subnet, you might be able to. I tried it before and it failed, but it could have been another issue. And then I immediately was just like, okay, one subnet per cluster, that's it. And by doing that, it also gives us the ability to automatically lock down every cluster via firewall rules as well. So that way one cluster isn't allowed to talk to another cluster through layer 4. Like, so there, you know, you have pods over here, you have pods over here. You can't just directly communicate with the pods. Like, I can't just hit a pod IP address, or I can't hit a cluster node IP address from another cluster. We don't want that. If you need to communicate with an application that runs on another cluster, we want you to go through the load balancer, because that's the route that we want you to take. If not, we're going to gonna set up a specific route that we want you to take to be able to communicate with that application. We don't want you just, you know, being able to talk to whatever. So doing one subnet per cluster makes that very simple because the firewall rules are automatic and they just work. So you create a cluster, you get a firewall rule. VPC service controls. So VPC service controls, it's more of a GCP thing, but it also works with the container registry. So you can lock down your container registry with VPC service controls if you're in a shared network to make it to where you can only hit your registry via the VPC and using the service controls. It also does some cool stuff like if you're using BigQuery, you can lock down BigQuery to only be accessible from your networks, which is also very, very nice. And then flow logs for each subnet and network, so that way you have all the logs. And then you're gonna have to pay a little bit of money for logs. So, sorry, if you don't want to pay for production, you know, I mean. All right, so master API security. So this is a big thing. This is a big thing for me. I think the master API needs to be locked down, no matter what. If your master APIs are open to the world, you need to leave and go lock them down because it's not safe. Pretty much all the CVEs that have come out recently. Last year there was like 3 that happened like within 2 weeks of each other. They were all through the API node. So like if you're not locked down on your API, if your API is not locked down, then you're just opening yourself up to new CVEs. It doesn't matter what version of GKE you're running on. New CVEs could come out at any time, and that is the way in. So that's what people are trying to hit, and that's what people are trying to figure out how to break. So just locking that down is like the first layer of security, and it's a requirement in my opinion. So also another cool thing. So zero trust. I know it's a buzzword, but it's also something that that is very important. It's not just a buzzword. By locking down your master APIs inside of a shared network in GKE, you allow your clusters and the applications that run on top of those clusters to be, and that's not related to the master API, but in general, you have the ability to set all your clusters and all your applications onto a zero trust network, which means that no matter where your users are, which are your employees that are using Kubernetes and or your employees that are using your internal applications that are running on those clusters, not every application is an external application. You can easily lock it down to your zero trust network, which means you only have a very small set of gateways that are all over the place in your networks that allow access through the gateways. So zero trust for me is a big deal because we're actually able to lock down our Kubernetes master APIs. So what we do is we don't let anyone talk to the public IP addresses at all. And instead, we only talk to the private IP addresses of the Kubernetes master APIs. So no matter where you are, you still have access to the private IP address of the master API, and that's through the Zero Trust network because the gateways that we have allow you to have access to the private IPs of the actual master APIs that aren't routable to anybody else in the world except for the people that are on our Zero Trust network. And that is just an application thing. So Kubernetes is just an application at that point in terms of zero trust. And that's the same for all other applications that run on top of the clusters. It doesn't matter if they get provisioned private IP addresses or public IP addresses. They're still locked down on the zero trust network, and they're accessible from anywhere. Not VPN. VPN is not zero trust. If you disagree, then we can talk. So, and the other thing is perform master credential rotation. And you do this because it rotates your master API, your master IP of your API, and then it also rotates the certificate. So if you do this, you know, at some regular interval, it also gives you another layer of security. So your IPs are changing and your credentials are changing to be able to actually communicate with the API. So, okay, internal security. Let's see, how are we doing on time? 7:38. What time does this thing end? I feel like I've been talking forever. It ends at 7? All right, sorry. When I'm done? All right, I'm gonna breeze through the rest of the slides because I have another picture that I painted and I really want y'all to see that. All right, so I already said firewall rules on the cluster. Lock down all your clusters by firewall rules. This happens by default in GKE in shared networks. So you're good. You get that for free, and it's very nice. Network security policies, pod security policies, Istio. Don't use it. Don't use Istio. I'm just kidding. If you use Istio, raise your hand if you use Istio in production. In production. There we go. Everyone, round of applause. Round of applause. All right. Very nice. Yeah. Okay, so also node security. This is important too. So IAM privileges in GCP kind of work the same way in AWS. Nodes come up. If you leave the default IAM security policy on each node, you'll get access to things like BigQuery, and you'll get access to things like GCS just from the node, just being on the node. And you don't want that. So delete the default, or just don't provision it with the default compute IAM service account, and create a new one with as minimal privileges as you need on the node. Really, you shouldn't need any, because all the privileges to communicate with those services should be done through your application via other service accounts that those are specified for. Your GKE cluster only needs access to Stackdriver pretty much to ship logs out. So GKE RBAC, this is pretty cool. This is something that we actually like a lot. So with the gcloud command tool, so who here has used the gcloud command tool? Okay, so pretty much most people. So you can actually just get an access token that you can use to communicate directly with your Kubernetes cluster just with this tool. And you can see that if you cat out the kubeconfig file that you use to connect to your Kubernetes API in GKE, you can see that there is a little command in there that has this snippet in there that just says like, okay, run this command to get my access token. And that access token is all you need to be able to communicate with the cluster. But what that means though is, since you're using an access token, now I know exactly who you are, and I have the ability to say, I know I want to lock you down to exactly what I want you to be able to do on the cluster. And that's done via RBAC. And so it's all through your email address. You just say, okay, blah, blah, blah. This access token is mapped to Josh Kurz at dub.com. You know, I don't have that email address yet. I'm working on getting it, but only Oprah has it. She has Oprah at dub.com. And our CTO and CEO, just kidding, Oprah doesn't really have a dub.com email address. So yeah, so RBAC with access tokens is a really good way to lock down your Kubernetes APIs. And that's because like you can literally say, so you can script out all your role bindings on all your clusters, and you can say, okay, these users are the ones that have access to this namespace and they can do X on it. And by using the access token, it makes it very, very simple for users to communicate with the cluster, and for you to lock down, for you to lock the cluster down to what they can do. You also get all the audit logs that map to exactly which command was done by which user if you force all users to communicate with the API through their access token. So that's really good. Node pools. So node pools is something that you So when you create a GKE cluster, you can either just create a cluster and say, okay, cool, it's good. It comes with the default node pool on its own. The problem with that is so the problem with it is if you're using any scripting tools like Terraform or the Google thing that's equivalent to CloudFormation, I forget what it's called. You can't manage that default node pool how you really want to. So you can't say, I want to provision all these things like node repairs, auto scaling, auto upgrades, and you can't specifically say I want these types of nodes running on it. Well, you can't say you want these types of nodes on it, but it makes it a lot easier if you're specifying. If you just delete the default and you manage the GKE API server and the API and the cluster itself on its own separately to the node pools. And this is because if you're managing them separately via, whatever you're using to manage it, don't just go into the console and create these clusters in production either. That's another thing. I didn't even put a slide up on that, but it's kind of obvious. If you're creating clusters in production, just use something like Terraform or whatever, Bash, I don't care. Just use something. Don't do it through the console. Because you get to be repetitive and you can make sure everything's done the same way. If you're doing it, yeah, okay, we don't have to talk about that. I didn't even create a slide for it. So you want to manage the API, the GKE cluster itself, and the version that it's on, and the security, the firewall security that it's using, all the other options that it has separately from your node pools, because you might want to make changes to your node pools and you don't want to screw up your API server. So by deleting the default node pool and managing the node pool separately, it gives you the ability to create preemptible node pools and standard node pools and node pools with GPUs on them and node pools with whatever else, super ultra high mem that have 5 terabytes of memory in them if you need them. So I would recommend doing that. GCP ingress controller is pretty sweet. Honestly, it offers a bunch of really cool features. Cloud Armor is a way to lock down your application. You just create a policy. You say only these networks are allowed to talk to this application at layer 7, and so you create a backend config. It's a custom GKE object. It's a custom resource definition that is applicable in GKE. So you would create a ingress controller, not an ingress controller. You create an ingress spec, give it the annotations that you want. You create a backend config, and in that backend config, you say, I want Cloud Armor, and I want it to be associated with this policy, and I want the Cloud IAP, which is the identity aware proxy. It's a super awesome feature. If you're not aware of it, you can just set it up in your application, say, I want Cloud IAP on this application. Then when you go to that app in your browser, it's just going to automatically redirect you to a Google login page. And it's going to say like, okay, who are you? You're going to log in through your Google account. If you don't have access to that account, it's going to automatically kick you out. Or if you do, it's going to give you access to it. So layer 7 security there at Cloud IP, layer 4 security at Cloud Armor. And using them both together makes your application very secure and running on the public internet at the same time. So that's a huge win. And it's very, very simple to use with the backend config. So I highly recommend, if you're going to use GKE, that you really look at using the ingress spec and using these layer 7 load balancers as much as you possibly can, because you get a lot of things from them. You get metrics. You don't get the metrics on the layer 4 load balancers. You don't get logs. Well, you get some logs, but they're not as good. And then you also get the other stuff that's up there, timeout, session affinity, all those things. And, like for me, honestly, metrics and logs, like if I don't have that on my load balancers, it's kind of useless. Like, I mean, it's not useless, but I really need to see like how many requests per second I'm getting. I need to see how many 5xx's I'm getting for me to be able to debug anything in production. If I don't have that, I'm like lost. Regional versus zonal clusters. So there's two options for GKE clusters. Regional means that you just pick a region, US East 1, and it's going to automatically provision, it's going to automatically provision worker nodes in each of your node pools that you have. You set a minimum in the node pool. So you have a node pool and you say, I want one replica or one node per zone. And it's going to automatically do that for you. So you don't have to worry about configuring things in each individual zone. And it makes things a lot simpler, kind of abstracts the zones away from you. The reason why you would want to go with zonal clusters, though, there is a reason. And that's because some instance types don't work in all zones. So if you're trying to run if you need 5 terabytes of memory, then, there are people that need 5 terabytes of memory, by the way. Then, those ultra mem nodes don't run in every zone. I don't know why, they just don't. And then if you need GPUs in every zone, some GPUs, they only come out in certain zones. So you have to create a zonal cluster for that. And so yeah, just think about the workloads that are going to be running on it first before you do it, because you can't, well, one thing is you can update from regional to zonal without deleting the cluster. So that's very cool. At first, so what happened is I was just like, okay, why would I ever do zonal? That's dumb. And then, so we just have regional everywhere. And then, we need 5 terabytes of memory. And I'm like, okay, well, that doesn't work. And so, my first thought is I'm going to have to delete the cluster and recreate it, but you don't. So that was really cool. Nice job, GKE. Project structure and container registry. So, projects in GCP are nice. It's just a logical way to separate your access to your clusters and to all the things that you want to give developers access to, versus just having a few accounts that you run, or 1 million accounts. But accounts are, no matter what, they're a little bit more difficult to manage. Historically, I think it's getting easier. Projects are just really, really simple to create and manage and dish out access to. So that's another big win for GKE, GCP really. So, all right. So, and then there's also all these alpha features and beta features that I'm not even going to mention because there's just too many. But it is cool to know that they come out with new stuff all the time. Literally, like while I was writing this, I learned about like half of this stuff that was on here. The biggest thing for me is managed certs, which is cool, and I'm looking forward to playing with that. But my bet is it's not going to be as good as ACM though. So GKE gotchas, these are things that just, like if you would have read all the documentation before you started, you would know this. But, I mean, who does that? So you can't. So this is one thing that's not even in the docs, but I guess it's just obvious. Everybody knows it except for me. So you just don't change your node ports on your services. Like if you're doing an apply on a deployment and you are automatically, if you're somehow changing the node port on a service that's already running, you're going to have serious downtime in GKE, like 5 minutes or more. Whereas in AWS, the downtime is like, seconds, but still there's downtime. But, it's just don't change your node ports. It makes things a lot smoother. You don't want any downtime. But that was something that GKE actually showed me that this was actually happening. And I was like, wow, I can't believe we're changing it. So we're doing historical legacy code calling replace on a file versus an apply. And that was updating the node port. And this is how the issue kind of came up. In GKE, it just caused this huge outage, and just like, wow, how come you guys aren't cool about me updating my node ports all the time? And then I was like, wow, there's no reason to update your node ports that often, so don't do that. So you can't use this network on a cluster master, and there's really no reason why, but you just can't do it. And then, yeah, there's some other networking issues with shared networks that are kind of gotchas, but I'll post these slides up. So if you want to look at these few things, so you don't have to slap yourself, you might want to do that. And then all the sources for the talk is here. Most of them are Google Docs, because that's all I could find. And then here's another painting. That's what I wanted to show you. All right, cool. That's it. Do we have time for questions, or did I go way over? Okay. Any questions?
Curious. So you talked about the GKE ingress. Does it handle DNS entries for you as well?
No.
So you have to do that manually?
Yes. I didn't even mention DNS. I should have. But yeah, you have to do DNS manually, or, however you choose to do it.
External DNS.
Well, yeah. I mean, yeah. You have to do DNS differently. So you just get an IP address, and then you got to figure it out.
You mentioned a lot about EKS. Are you trying to move to it, or running a cluster there, or right around?
What did I say about EKS?
Well, you were mentioning at the beginning, like EKS.
Okay.
EKS. You talked about ACM, and also.
Oh, yeah. So ACM is the best. EKS, it's not. In my opinion. But no, I mean, we're like, definitely EKS is still in the top running of what we want to use. But long term, though, just from what we've seen, and what I've seen, really, GKE has just far outperformed the ability to upgrade, the ability to stay up to date, and the ability to just run correctly. EKS is good. Don't get me wrong. Like, it's a great platform, but in my opinion, it's behind GKE. So if we're gonna do it, the only reason for me why I'm definitely going to use EKS is because there's applications that are in AWS that we're just not going to move out. And so networking wise, it just doesn't make any sense. But there are, yeah. No, that we have, so the majority of applications, it doesn't matter where they run. There's a small subset where it does. So
we've been playing with managed search data and has a bunch of rough edges. What do you do for managed search? It seems really hard.
Yeah, I mean, we just use Let's Encrypt and just create the certs, and then we started out just updating them whenever they would expire, and then so that really sucks. And then using another automated tool on top of that. So hopefully the managed search stuff is going to be, decent. Wait a second. This is oil. Yeah, I mean, it's Bob Ross, so it's got to be oil. If you're not using oil, then you're not a true Bob fan. Yeah, you can see how wet it is. And then right here was my 1-year-old actually just went up to it and just put his fingers all over it. But it doesn't matter because there's no mistakes, only happy accidents. So I was just, fix it. So it's all good. WW. Stateful sets? What are those? Yeah, all the Kubernetes stuff that we do is in the cloud. Pretty much at this point, I would say COP stuff is analogous to on-prem stuff. I know it's not, but it's just like legacy stuff. COPS is pretty much as far back as we go in terms of legacy. Do you have a question? No? Okay. Istio? Well, there's a lot of things. One of the things I didn't mention about GKE that's so awesome is you can just install Istio. It's just, you know, click of a button, and then you can uninstall it super fast. So it makes it really nice. So we have, I don't personally work with Istio. What the majority of my work with Istio is, hey, there's a problem going on in non-production, and I'm like, oh, well, we just updated Istio, so yeah, that's the problem. So that's pretty much been my issue with Istio. Is literally everything we do with it breaks everything else. So that's kind of why I don't like it. But you know, it's getting there. We're almost there, and that's why the next talk, hopefully, is Jason going to be talking about Istio. That's why I'm here, is to get Jason to do it. Anybody else? No, we use the NGINX ingress. We do for certain things that we need it for. We've used it for a long time. I just didn't put it up here because it wasn't specific to GKE. But yeah, no, the NGINX ingress is awesome. I love it. Anybody else? I know you had a question. No? Okay. Fine. Yeah. Hey, no problem. Thanks for having me out here, y'all. Appreciate it. I don't know. I'm kind of confused about the question, just a tad bit, just a teeny bit. Can you clarify it a little bit? Mm-hmm. Yeah. Mm-hmm. Yeah, for sure. I mean, security is a super high objective at WW. So we make sure that everything we do is as secure as possible. And so that's why we're so focused on it. Yeah. I mean, to be honest with you, like, I'm not really here. Like, I'm not even branding this talk as WW. So it's not even a WW talk. Like, this is just a GKE talk. So I honestly, I don't know. I don't know.
We actually have a question from online.
Okay.
He's asking, given an option, which service mesh would you choose, Istio or Linkerd?
Well, so, well, no. So I would choose Linkerd if they used Envoy, and that's because I feel like Envoy is the chosen proxy for service meshes, just because of all of the other, like, AWS has a service mesh application that's come out that is built on Envoy, and everybody, and everybody else is building things on top of Envoy. That is like to me, that is obviously the proxy of the service mesh, or at least what it should be. So I like Envoy a lot. Istio is what, the control plane is what bothers me a little bit. And it's just because of the configuration and how they're doing things. And I know it's going to come out, it's going to start working eventually. I mean, it's like right there. It's literally like their latest release is like, it's good. So we're really close. But yeah, if Linkerd could use their control plane with Envoy, I would definitely use it, or at least I would really look into it. But I just don't like that Linkerd has their own data plane that is only specific to them and they're coupled together. I don't like that.
He says we want to decouple and no one vendor lock.
If Linkerd like came out and they were like, hey, boom, we support Envoy with their control plane, that would be the bomb. For sure. That's cool. Linkerd. Yeah, I mean, you got a sweet control plane. And your data plane is awesome too. It's just everybody else uses Envoy. Yeah. Cool. Well, it's been really awesome. Just want y'all to know it's been hard also because I haven't been able to hold a beer and talk at the same time. So yeah, you want to buy one? The highest bidder. No, go for it. What? No. Okay. All right. Anybody else? All right, cool. Thanks, everybody.
All right, cool. Thanks, Josh. Like I say, next month, the third Wednesday of June, we will be at Full Story's new headquarters. We'll be sending out more, and I'll let you speak in just a second. And we do need speakers for that. If you want to hear more about Istio, you should harass the guy back there named Jason. We tried to nerd snipe him into talking tonight, and he said he didn't have enough time to prepare. But in the meantime, if you want to speak or whatever, just please let us know and want to sponsor, et cetera. Did you have something, Sean?
Yeah.
Okay.
Also, VMware is hiring, so if you're looking for a new SRE role, come hit me up.
Have you bought and crushed another open source company recently?
I hope that we can buy and still crush more.
Sorry. Well, next KubeCon will be nothing but a VMware booth out there. I'm kidding. No. Anything else? If not, everyone, Moshe, you'll let us know when we have to get out, right? So otherwise, mingle, talk, chat, complain about Istio or whatever. So thanks.